So I don't wear my black shirt today, sorry, but it's because I'm here for my presentation. Which tries to educate like young people and children to sciences and technical activities. So today I will talk about SqueakBot, which is a pedagogical platform for educational robotics. It's a set of hardware and software to help like children from 11 to 18 to build robots easily. So this presentation will take about like 20 minutes, and I will be glad to answer your questions afterwards. First, I'm gonna talk a bit about like the organization, then I'm gonna like focus on pedagogical aspects, then present like the platform itself, and give some application examples. Okay, so Science is a non-profit French organization which proposed since 1962 some scientific and technical activities for young people. They take the form of some accounts or they go classes, etc. So this association is divided in several sectors, including sectors in charge with robotics and IT. And so every year we like make activity for about like 50,000 children. So now I will focus on the pedagogical aspect of robotics. So that's how we teach robotics to children. So basically, you've got a robot which is evolved in an environment. So the robot must detect things going on in the environment. So things and decide on this aspect, and then act on this environment. So basically, a robot is a set of sensors. Detect, so you've got like switches or telemeters or whatever you want. Detect, so you must have a kind of intelligence, and then act on this environment thanks to motors or servo motors or any set of actuators. So when you make robots with children, you're not working with engineers, so there are some specificities. First of all, children are children, and so they must. The learning curve must be fast, because if they are to learn a new language, if they are to learn like very low level instructions, they will get bored and they will say, okay, it's not funny, I'm leaving. And moreover, they must use their native language. In that case, it was French. And the most important, they must have fun while making robots. Not like in a
What age are they?
We do robotics with children from 7 to 18. And this project has been tested with children from 13 to 15 years old. Of course, we adapt our activities with the ages of the children. Usually, they do not have a technical background because they come from secondary school, where they know how to use the internet and all these things. The proper technical background. The problem is that building robots involves a lot of tedious electronics and programming, and you must deal with the mechanical aspects of your robots too. So it's not very easy to do this. Usually we work with very short period of time. We do some accounts which last for 2 to 3 weeks, and usually we've got from 2 to 6 hours of science a day. So that's a really short time to build a robot. What we try to do is to build ready-to-use electronic modules which can be programmed easily. But these modules must not restrain like the creativity of children. We must like let them experiment and create their own projects. We don't make kids, you know. It's not like, okay, so you've got your electronic parts, you've got mechanical, just assemble them according to a plan. That's not it. We must believe creativity. We want them to learn, and the best way to learn is to experiment. So we developed several modules which could be interfaced with Logo. Logo was and is still a pedagogical language where you could program what you call a cursor. And that's it. So the problem is that Logo is still like old. Yeah. And well, first of all, our version of Logo works only on Windows, and we're trying to migrate on Linux at the moment. We wanted to develop something that was cross-platform. And with Logo, you still had to learn syntax, which was not really easy for children from 7 or 9. And we thought that object-oriented approaches were more natural to modulate robots. You know, you've got your object, you've got your robot, and you can have object for yourself. So we chose to develop an open source quick ESUG approach in partnership with the University of Caen. We started this project several years ago. And so we developed I will present the electronic interfaces that we use, and then I will come to the software aspect. So the first module that we developed is called SMEC, which is Super Module Électronique de Commande, Super Electronic Command Module, because we had another one but different spelling. Super. So this module can control one or two DC motors, that is, you can say, okay, on or off, you can control the speed. And we have 5 binary inputs, on or off. And so we can connect several of them to control several motors, thanks to the I2C bus. So that's it. And so it was not we could only control motors on or off, or saying backward, forward. That was not enough. We decided to develop another card, what we call RC, because we could have this time we could have analogical inputs. We could have, I mean, it was not on or off, but you could measure things like light or whatever you wanted, just proper sensors. And this card can control 4 servo motors. Servo motors is a motor that you can control the angle if you put a specific tension inside. And since this card, the one before, had to be connected thanks to the parallel port, and well, you don't find parallel ports on computers anymore. We decided to use USB port. And the thing is that the firmware inside, the program we put in the card, can be modified in open source. That's the main thing. And you've got a remote control for the developer. So you've got a card, you've got here you've got the 4 motors you've got analysis going to input here, etc. I've got one of these with me, so if you wanna have a closer look, just ask later. Okay, so now we've got all these electronic interfaces. So we can use actuators and sensors. But what about the robot brain? So how to program it? So we decided to use for pedagogical purpose ESUG-like interface. So for those of you who do not know ESUG, first of all, that's a shame. That's, in my opinion, one of the funniest parts of Squeak. Well, anyway, it's just like the blue eye in the halo. You've got a world of opportunities opening to you. So ESUG just involves like you program by basically you just drag and drop some files into script, and you've got like your nice program. It's really easy to catch for children. It's very intuitive, and so if you've got no prior knowledge of programmation, well, you just can drop and since it's a natural language, and you don't like it. And when you got accustomed with it, we've got like the possibility to use a small syntax to program our robot, which is intuitive too. So our interface looks like this. You've got like a more model of our interfaces. You can click on it and give some instructions directly, or you can script them, and you can model your robot and just direct instructions. It's like a remote control, because yeah, it's a robot. It does need to be connected to the computer. It's not autonomous robot. Well, you can make a script and do something and have some stable function. So just a short slide on implementation, so SqueakBot it should be cross-platform. It's using a plugin to communicate with the USB port, which is stereo port. And we've got some classes on the I2C protocol, which is a protocol we use to communicate with our cards. It's easy to catch. And we've got classes representing the real devices. So, I mean, easy to catch. You've got your card, you've got your model, this small-top model, and what you see, but they are the same thing. So, now I will give you some application examples. So it will be clearer. So most of them are taken from an experiment we conducted in 2005 in a summer camp. It was a summer camp with children from 13 to 15 years old. So we just presented Squeak priorly. I mean, we had there are 2 hours to discover how to use it, etc. And those interested in robotics could continue. So, one group of them decided to develop a Mars rover. So this thing will be sent on Mars a few months ago. Yeah. So you see, you've got 6 wheels. What? 5. And so you've got DC motors, on or off. I mean, if you invert the polarity, you can go backward. And so we have 2 of these control modules, which could control this side or this side, and so there are sensors to control all the things. So you've got the creator himself. You can see, I don't know if you see, but you've got the 2 snakes over there. Well, okay, so another example. One group decided to make a walker to test other type of movement. Does it remind you of something? I don't know. Your Star Wars? Well, pretty much the same thing. So this time they have to control 4 motors independently because they wanted to test how quadrupeds, that is, animals with 4 legs, were working. So they did some experiments, they made gas scripts and research on the internet how animals were actually walking. and they try to reproduce the movement. Well, it didn't work. We had some mechanical problems. It's just like cardboard and wood. But, well, they did their experiment and they learned some things. They learned how to adopt an experimental approach. And, well, that's what they were doing. So we have like this kind of caterpillar robots, like. I've got a video of this one, by the way. If I find it. So we've got many videos. Google video, just type planet science and you will find it. Resolution problem. Okay. Didn't tested it before. Anyway, so you have like a set of 3 servo motors, and well, it's actually it moved. They first made performed some tests, and actually they found get this moving. And last project, which was not made by children, this one, but during a formation like several months ago. This one is intruder detector. So you've got like an infrared telemeter, which can distance it, and if you get too close, it takes a picture. Yeah. The interesting thing is that I mean they had to calibrate the sensor, because you know it was not like it didn't give like you know a linear value. I mean if you had this kind of curve, then it was you have the value of the sensor, you know, the output tension on the left and right on the right side if you've got the distance. So well, they used ESUG to calibrate the sensor, and it was quite nice. Okay, so to conclude, so this project allows children with no technical knowledge to develop robots. I mean, they arrive here in Costa Rica and say, wow, we want to build robots, but we don't know what to do. And when they come back, they say, oh, Mom, Dad, I built a robot. Wow. Okay. Still, most of the time, I mean, these robots don't work very well, but I mean, they have been sensibilized to scientific and technical culture. That's the goal. Thanks to this platform, we've got fast results, which keeps the motivation high. I mean, just imagine your children come to your semester and say, okay, we'll program microcontroller thanks to assembly language. So first, read the documentation. Well, maybe after 2 weeks you will get, well, segmentation fault. Yeah. So we need to keep the motivation high, because, I mean, children get bored really easily. So we tested this in the summer camp. And now this project is part of a larger project called SqueakBot, which contains everything needed to build robots which you have. You've got your car, the brain of the robot. You've got like motors, like sensors, and you've got sensors. You've got like light sensors and so on. So this one can be used in classrooms or.
CD with SqueakBot. There is a CD with SqueakBot in the back. Yeah.
Yeah. Because we use Squeak for several purposes in this organization. This summer in July, I worked with teenagers from 15 to 18, and we made some simulations into Squeak. They were not connected to electronic arts, but we made some movement simulation. Yeah, it worked quite well. So now, for the perspective, well, it works on Windows. There have been some problems. It still does not work with Linux and Mac. Any Mac users around here? Well, we still have problems with the USB port only, but well, it should be fixed soon, I hope. Well, 20 of these kits in production at the moment, so we will test them like from September. So we'll get some more results, and next year I'll come and make another talk on SqueakBot, etc. Well, so why do we spend so much energy in this project? Well, just for this. You see, look to this. It's having fun and well, just running more things. So if children have as much fun as us while using small code, I mean, it is definitely worth it. Thank you. So here are some links if you want to know more about like the organization, or to download like the source code. We've got more information. Thank you. Do you have any questions? Yeah.
Can you buy the box?
You can, well, we didn't finish to produce them yet, but yes, you can buy it. I mean, you just, everything is here. Or, well, it's in French if you want to know more about it. You can buy it. Yeah?
This involves French at the moment. Is there a way to apply another language?
Yes, I mean, because we just use like the French translation of Squeak that has been done like how many years ago? Well, like 2 years.
2 years, yeah.
2 years ago, yeah. So I mean, you've got ESUG translated in German, for example. I mean, you can use it in German too. I mean, it's just about like the ESUG interface translation.
It's in English too.
Yeah, Squeak does exist in English too.
In Japanese.
And in Japanese. Another question? Yeah?
What about different microcontrollers, cards? For instance, there is Arduino.
Sorry?
There is an open source hardware project called Arduino, which is based on, it's not a PIC, but another microcontroller, and I think it works with USB, Bluetooth. And
The thing is that I mean, we developed all the I2C layer, which is like the protocol which has been developed by Philips to communicate easily with it. It's not really robust, but it's really simple to understand. That's really important when you work with children. Keep it simple. I mean, you can use what is done in SqueakBot to communicate with any I2C device. I don't know how it works, but well, I mean the PIC program is independent, which is, you know, it has been like written in C, so don't mind all the things, just like using the I2C protocol and USB port. Yeah.
Is there any relationship of your work to the work that has been done in Douai, at the department where Marie is?
You talk about like Wikitalk?
No, I'm talking about the robot work.
No. Not yet.
Not yet. Soon.
To interface to the Lego Mindstorm?
No, we didn't, because we don't. I mean, we chose to not use Lego Mindstorm in this organization. First of all, it's expensive, and you know, it's very close to the kids. We make children start from scratch. But well, and you, I mean, Serge, did you? I thought that you could interface Mindstorm with Squeak.
What? Interface with what?
Lego Mindstorm.
No, there is no.
No, because we deliberately choose to start from scratch, because it's more like pedagogical. And they've got nothing, and they've got to work.
Just a comment there. So I've been working a lot on Lego Mindstorm. So if anyone is interested in having good behavior for Lego Mindstorm, I've been working on it.
Yeah.
How many people are in this pilot trial?
Well, we constantly form, so we train people to use Squeak. I mean, originally we were only like Serge, me, the guy Stefan, and Samir Saidani.
4 people.
But now, I mean, we train people. We recently, it was in June, we train trainers, and we propose some formations to use Squeak as a pedagogical tool. I mean, we teach like basic deploying and SqueakBot. You know, remember the like famous drive a car, example. So make some transport. Because I mean, Planet Science is involved in training.